Okay, good morning class. So today we're looking at exercise 7.13. It's the same thing as the previous lesson. So let's just wrap up this chapter. We're spending way too much time here on this. Looking at 7.13. So now we're going to look at restrictions on identities. That's your reading for today, for this part of the lesson. Restriction on identities. When proving identities, we may be required to specify those values of the variables for which the identity is not defined. We need something undefined. There's no solution, yes? When else? Sorry, when you're dividing by 0. Not like 5 over 0, that is undefined. Okay, undefined. Alright. Where else do we find where a graph is undefined? On your sine, cos, and tan graph. Sine, cos, and tan. When we're looking at the asymptotes on your tan graph. Not so. That is also a point on the graph where the tan graph doesn't actually.
Can I have your attention, please, learners? Grade 10s who wanted it like blood, can you please come down to the.
Okay, so we said on the tan graph, when we have the asymptotes, that's also a point where the graph is undefined. So whenever you see a tan of theta, immediately it is going to be tan of theta, then theta is equal to 90, and that asymptote repeats itself every 180 degrees. Okay, so for the asymptote, just remember if you're looking at the tan graph, for those of you who are confused, this is what it looks like, that's 90 and that's negative 90, not so. The sum is undefined here. As you can see, the sum doesn't cross this 90 minus 90. But this happens every 180. So for whenever you see a tan, and this was tan of theta, then theta is equal to 90 plus k times 180. Okay, so that is for tan. Just remember that, okay? So let's read what they are telling us here. So here we are saying, when proving identities, we may be required to specify those values of the variable for which the identity is not defined. This is 7.13. Eh? And 7.13 is on page 251. And this here is example. I'm going to do now the first example, which is on page 250. Okay. Sorry? Okay. So an identity contains an identity containing a function tan alpha would not be defined for alpha is 90 plus k. This is exactly what I just said now, okay? Where k is an element of integers, since tan alpha is not defined for any of those values of alpha. An identity is also not defined when the denominator is 0. An identity in the form of g of x is equal to the square root of f of alpha, or g of alpha is equal to the square root of f of alpha, is not valid for those values for alpha for which either f of alpha or g of alpha is negative. Why? Because under the root we won't get a negative, or from a root we won't get a negative. Okay?
So for g of alpha?
G of alpha. Well, listen, if you got f of x is equal to 3x, not some squared plus 1. Now if you say f of alpha, this can be equal to cos of alpha. What's g of theta is going to be sine of 2 theta, and so on and so on. Okay, it's just a naming for your graph, for your function. Okay. With that in mind, people, let's go. Example 1 is on page 250. The question says, now here they're not asking us to prove this identity. We have proven this identity in 7.2, number 3. Okay? However, this question is, for which values of beta is the identity undefined? So firstly, is there a tan? No. Because if there's a tan, the first thing I would write down is x is an element, or beta in this case would have been equal to 90 plus k times 180. Since there's no 10, I don't worry about that. Okay. So where else is it undefined? Is when the denominator is equal to 0. Yes, it's when the denominator is equal to 0. So 1 plus sine beta is equal to 0. That is where it's undefined. Okay? Alright, so we take it over the equal sign. What do we get? Sine beta is equal to negative 1. So what did I say if it's negative 1, 0 or 1? We take it to the graph, yes. So we draw the cos graph or sine graph? Sine, so that is sine. There is a sine graph. That is 1 minus 1, 360. So where is sine equal to negative 1? At 270. So how do I represent that? I say x, or beta in this case, is equal to 270 plus k times. The solution will happen every 360. Okay. So if you put cos of 270 over 1 plus sine of 270, you get undefined. Okay? Or you put it, yeah, on that side you get undefined. Let's look at the other side. The other one would be where cos of beta is equal to 0. Not so. So with this 0, 1 or minus 1, what do? I take it to the cos graph. So that is 1 and negative 1. So this is 360. So where is cos of beta 0? At 90 and 270. Can you see that, people? But what do you notice? That is already 270 plus k times 360, which is this one here. So I don't have to represent that one. You guys understand? Yes. But if you go with this 90, x is equal to 90 plus k times, the solution happens every 360 degrees. If you are not going with the fact that that solution will happen there and there again and so on and so on. Otherwise, you can just tell yourselves, okay? But there's an easier way of writing exactly that. Why? Because the solution is at 90 and 270. I can just say beta is equal to 90, and this is happening every? Sorry? How many degrees is that happening every? From 90 to 270 is how much? 180. So if I extend this from there to this point, it's also going to be 180. From there to there is also 180. So this solution will happen every 180 degrees. Okay? Where k is an element of integers. But if you look closely, if k is 1, then what is the solution? 90 plus 180 is 270, which picks up that one as well. Okay? So when you come to this part of the work, you will see that the solutions that overlaps. Okay? I'm here to just leave both. Okay? The marker will come and give you full marks at that one. Okay? But as I said, if you had only written this one, you'll also get full marks. But you're not always going to know when to stop. You understand? So if I'm you, I would just go all the way and you'll get in the full marks all the time. You had made no mistake. Okay? Rather safe then sorry. Right? People, any confusion here? Any confusion? No? Example 2. Example 2 is on page also 250. Example 2 on page 250. Example 3 is also on page 250. Right. The question says, for which values of x is the identity 1 minus sine squared x over cos x minus sine x equal cos x plus sine x undefined? People, is there a 10? No. Right. So when will this be undefined? When the denominator is equal to 0, which says cos x minus sine x is equal to 0. So what do we do now? General solution, not so. So what do I take sine? over the equal sign, which now gives me cos x is equal to sin x. Are the angles the same? So I can divide both sides by cos. Why by cos? To get tan x. So that's going to give me tan x. What's cos x over cos x? So if I take that to the graph, the tan graph. And then we'll be a bit closer. Oops. So where's tan of x equal to 1? At 45 degrees. Not so. So how do we write that as a general solution? So x is equal to 45 plus k times 180. Where k is an element of? And of course you can test it, okay? If you put 45 on this side, you won't get, you'll get the root 2. But if you put 45 on this side, you'll see it will come to be undefined. Okay. Last one, people. And with that, you should be able to do example 7.13, which is on page 7.13 is on page 251. Okay. And last one. People, do we see a tan here?
Yes.
Yes. So what's the first thing we write down? First thing we write down is, because of the tan, theta is equal to 90 plus k times 180. That's for your asymptotes. Right. Where else? Is where cos of theta? Where cos of theta is equal to 0. So 1 minus 1 and 0, we take it to the graph. The cos graph starts on top. So where's cos 0? At 90 and 270. So the solution happens every 180 degrees. So for that one, it's going to be theta is equal to 90 plus k times 180. But it's hang on. Hang on. That's in the same. Did I need to have written this? No. But did I know before I wrote it? No. So I do it anyway. Then this one here, is that equal to 0? So it's 1 minus sine theta is equal to 0. You take sine over, so sine of theta is equal to 1. Remember, 1 minus 1 and 0, we take this to the graph. Which graph? Sine graph. So we sine equal to 1 at 90. But for this solution, theta is equal to 90 plus k times. What's going to happen when on the next cycle? So it's 360. Anyway, hang on. This actually covers this as well. So that is the solution they are looking for. Okay? Where k is an element of integers. Okay? But if you can see it already after you draw the graph, okay, it's the same solution, then you don't have to write the general solution. Okay? People enjoy the weekend and preparation for your upcoming exam. Yeah? Good morning, class. Full lesson can be found in the description box below.